placard. For each of them. Is that good?
It's from a hand wavy part.
Okay. That's good. It's LLMs, it's all hand wavy.
Oh, I'm not doing LLMs this time.
You're doing deep learning
Yeah,
generalization.
deep learning. I mean, LLMs are deep learning, right? They're part of it.
Ready to start?
No, I'm thinking that's April 10th is LLMs.
Yeah.
Okay.
Woo!
Let's go! Yeah! Okay. Do we need to do anything on this? Okay.
We're live.
Okay. Welcome!
Woo!
Hey, do you have a microphone? I don't know. Do I have a microphone? Do you have a microphone? Yes, get a microphone,
This is
please.
my microphone.
Not everybody can talk
Do I
like
get a
me.
microphone? Okay. I mean, I can just.
I can't clap even.
No, get a
Hello.
microphone.
Oh, like that kind of microphone. Oh my god, now I'm gonna have to like.
You don't have to.
Because I'm gonna be holding my mouse. So then I'll be like, double dual wielding.
You'll figure that out well. Okay, cool. Hello, and welcome to Data Science DC and deep learning generalization, why it matters, and innovations for AI advancement. This is not. What am I doing wrong here, Will? I'm like. Thank you. Okay. Talking. Okay, is that better?
Yeah.
Okay, good. Let's go with that. Okay, let's try that again. Welcome to Data Science DC. Okay, much better. Okay, so today we're going to be talking about deep learning generalization, but first, we're going to be going through some community announcements and all those good things. So, Data Science DC is part of the larger network of groups under Data Community DC, which takes care of our website and our fundraising and all those good things. So, yeah, and okay. So there are a number of other groups, including Data Viz and Generative AI DC. And if you want to run a meetup at any point, we are always looking for more volunteers and more groups and all that fun stuff. So talk to me, talk to Will. And again, Data Community DC will take care of all the hard stuff. All you have to do is find organizers and tell us you want to meet and the fun things. Okay.
All fun.
Okay, thank you to our sponsor, Rotational Labs,
Woohoo!
for helping to fund us, which is great. Okay. And big thanks to Excella for both hosting us and feeding us.
Yeah. Woohoo!
Okay, so organizers. So Janet, who is not here tonight, Jeff, who is running the video, and me, we are the organizers. You can find us on the internet at various places, including LinkedIn, and since I'm sitting up here, I'm just going to say I have a blog.
Yeah.
I don't like those words. They're like very cringy words, but nonetheless, there it is. Okay, it's about LLMs. Okay. Code of conduct. Data Science DC is dedicated to providing a respectful, harassment-free community for everyone. If something comes up, come to me, come to Jeff, talk to Will, and our code of conduct is on our GitHub page. Okay. Data Community DC believes that inclusive and equitable communities are better and stronger. Same comments, talk to Jeff, and I will also say on volunteer labor. I shouldn't use the word labor. Labor makes it sound much more onerous. But if you're interested in getting involved, we would love to talk to you. If you want to get a talk, if you want to host a meetup, anything you want to do. Like you're thinking, I'm not the person to. No, you definitely are. I'd love to talk to you. Okay. So you can subscribe to our YouTube channel here. You can join us on Slack. Okay, community announcements. So this is where if you are job searching, if you're hosting an event, if you are hiring, raise your hand, stand up, and give us a short announcement.
Sure. Hi, I'm George. I work for Fable. It's a small startup around book clubs. If you are a senior-ish data engineer and you love Python, you are familiar with cloud environments, please come talk to me. After this, probably at Courthouse, though.
Oh, right. After the event, we go to Courthouse Social, across the street, and we continue talking, and sometimes code comes out if you really want it to.
I'm looking for jobs. So I got my PhD from UPenn. My research has been focusing on computational physics. and then I got really interested in machine learning, so I get like some publication on that and make sure that works. So I'm currently working as a machine learning consultant at some finance company, but I'm actually looking for a job right now. So the position I'm looking for is a data scientist and machine learning engineer or any AI-related role. So if anyone's hiring, so I'll reach out to you, or if you can reach out to me, that was great. Thanks a lot.
Cool.
Ethan, bye.
Thank you then.
Hi, I'm Andrew. I've worked in DevOps in some capacity for 12 years, and so I've been on disability for a while, and I'm looking to get back into the job market. Most of my experience is with server configuration, specifically Nginx and CDN configurations, which in our case was mostly Akamai. Or if you just want to talk public transit and travel, I'm happy with that too.
Cool.
Thanks.
Thanks.
Hey everyone, my name is Timmer. I'm with the Washington Post. We have 2 openings right now, one for a junior data scientist and one for a principal data scientist. So yeah, find me after.
Thank you for coming. I totally drafted the post an email about that. I'm glad they sent some.
Nice.
Yeah. Hi guys, I'm Abhijit. So basically I have like 4 years of experience as a data analyst. I'm good with SAS and Python. So currently I'm a student at George Washington University, currently pursuing Masters in Business Analytics, and like I'm looking out for internship opportunities in the summer.
Okay. Hey, hello. I'm Stephen Ho. So I'm doing this for my wife's company. So my wife works for Aesthetics, which is a biotech company at Gettysburg. They're hiring a senior scientist, machine learning and protein design. So if you're interested, yeah, come to talk to me. Oh, but actually I will leave early today, but you can like in meetup.com find Stephen Ho and just message me if you're interested. Thank you.
Hello, I'm Prima Roman, and I'm the Senior Machine Learning Engineers at Rotational Labs, so one of the sponsors for Data Community DC. So just to kind of briefly tell you about Rotational Labs, we help companies build AI products, so basically helping them come up with use cases and actually deploying these solutions into production so that they can recognize revenue. So if any of you are interested, kind of new to this space and would like some help, we offer free half-hour consultations to kind of help you brainstorm different use cases. So come talk to me. I'll be over at Courthouse Social, and you can email me as well. Also, we just recently created an AI playbook that, for those who are not familiar with machine learning in general or just building machine learning products. So we are happy to provide that to you. If you send me an email. So I am at prima@rotational.io. Also, in about a couple of weeks, I will be presenting a webinar on planning and scoping large language model projects. So if you're kind of thinking about starting a project and how do you actually plan and scope and try to figure out like how you can actually build and deploy it, come attend the webinar. It's virtual, and there's also a recording after, so if you can't attend in person, attend live, you can watch the recording later. So this is at the Rotational website. You can register. It's at rotational.io.
Cool. Thanks.
Hi guys, some of you might already know me here. Hi Benji. My name is Sunny, and I'm a recent graduate with a master's degree in physics, and currently I'm looking for jobs as a recent graduate. So my background, I got a master's degree in physics, and during school I applied machine learning, particularly deep learning, into like physics research. So I love data science, I love math, and I'm going to continue doing that like now that I'm out of school. So if any one of you know of any like entry-level data scientist position, please do let me know, and I would definitely love to talk to you some more afterwards. Thank you.
Cool.
Hey guys, my name is Vic Kumar. I'm an application architect for Bloomberg Industry. I probably should have checked with HR, but I'm pretty sure we have a lot of positions for data engineers, data analytics. We do some pretty cool stuff with large language models, including Llama, Mistral, summarizing tax documents, named it, all kinds of crazy stuff going on. So talk with either me, Kyle Mulca's back there. He's also one of our senior application architects. Yeah, we're looking for a lot of data engineers, so I'll be at the happy hour after this, so feel free to talk to me.
Hey guys, my name is Joe Coster, senior ML engineer. I've done a lot of work in NLP, building NLP models, deep learning models, deploying models, building microservices, etc. So that sounds like something you might be hiring for.
Cool.
Hi, my name is Hillary Roberts. I'm in the data visualization space. I have experience in SQL, Power BI, Tableau, that sort of thing. Also have a background in communications, so I think that pairs nicely with it. So if you guys know any opportunities, feel free to come chat with me.
So hi, my name is Eric. I am a writer and artist, and I am also just looking to get into opportunities within the technical space. I've done work with Weather Service, NASA, NOAA sort of things, and also I'm interested in doing other sort of things with legal documentation as well. I'm pretty good at that. Finally, I also mentioned I was an artist, so I have a booth open at this thing called Artmatic. Maybe you guys have heard about it. So that is going to be at 21st and M Street. It's completely free. It's going to be open a few days out of the week. Only closed Monday and Tuesday, but yeah, please stop by. Thank you so much.
Hey, Leslie Welch with Excella. Will Angel also with Excella over there. I'm just going to read off our data-related opportunities. We do have other ones as well, so Excella careers if you're looking for something else. We are currently hiring an Azure cloud engineer, data scientist, Power BI developer, several data engineers, and a senior DevOps automation engineer. And I also just wanted to call out that next Monday here, Women Who Code DC, we're doing a panel on neurodiversity in tech. Next week is Neurodiversity Celebration Week, so check that out on Meetup.
On that note, I am Mary. I am a co-director for Women Who Code DC. As Leslie pointed out, we have a Neurodiversity in the Workplace event coming up next week. Very excited for this. We also have a Kubernetes workshop on networking and security fundamentals. This is the third in a series of workshops. We have the other two recorded on YouTube. That's virtual, and that's going to be on March 28th at 4 p.m. Check our meetup out. And we also have another event that we are co-hosting with Data Science DC. Oh, yeah, nice. Perspectives on large language model evaluation. So it's going to be a panel. It's going to be here. It's going to be great. You guys should sign up. Take a look at the meetup. Yes.
Who's going to be leading the April 10th meetup?
Like leading, like the like who's on the panel or?
Yeah.
TBD.
Oh, okay.
We'll get there.
We're hoping. Yeah,
would you want to?
you should
master
talk
yet?
about
Some cool
You know, if
people
you're
for sure.
Yeah.
Sign up a meetup.
Yeah, if you're interested in being on the panel, like come talk to us, me or Abigail. We're open to that. So yeah, that's all I got for you guys.
Cool. Sweet.
Okay. Anybody?
I'll go last. Hello everyone, I'm Kurt. I came late, so I didn't get to meet anybody. So to try to make this full circle, I work in procurement for the government. I'm here on behalf of myself though, so I don't speak for the government in official capacity. And if you guys got any good ideas, I'm open to hearing some of them.
Cool.
Thank you.
Wait, you're trying to fix government procurement? I mean, like, I have all sorts of ideas. Really? Okay, cool. And JK you've got ideas. Okay.
Will.
And in addition to talking to you about careers at Excella, if you're interested in volunteering for Data Community DC, especially potentially interested in running a community survey, you should come talk to me. Also on Thursday, the Data Visualization Meetup group is going to be back here in this room for a hands-on data dive for the Data Viz Society's State of the Industry Survey. Fun stuff.
This is awesome. So many great announcements. So many people connecting here. This is great. Wonderful. I'll just say, Prefect, my employer, is also hiring in a variety of different roles for software engineers and developer relations and sales engineering and all kinds of things like that. So come talk to me if you're interested in that. We're workflow organization management solution.
Okay, and our next event. So Mary spoke about the April 10th one. May 14th is not on the calendar yet, but Alex McLean, who is an AI ML engineer at Grok, which is like the super fast LLM thing, is going to talk about chip architecture for running LLMs.
Cool.
So super excited about that. I'll get that on the calendar soon. And thank you for attending. Thanks for being a member. And this is where I showed a slide that is the same slide as this, and I didn't. But Elliott Miller.
Got it.
Is it attached to me? No, let me drop it. Attach, drop, same thing, right? Drop table.
Drop table. It's better than a drop table.
Yeah. Drop mic over drop table in.
Oh, that's a database reference.
Yeah. It's a double entendre. They're both bad.
I'm an ML engineer. Amazing. Let me just. All right. So deep learning generalization. I don't know if anyone could tell this, but the title that's on Meetup.com, I made with ChatGPT. Just full disclosure. Yeah, so this is just going to be a general deep learning generalization talk. A bit about me. I've had lots of different roles technically, from data scientist to machine learning engineer to analyst to all different things. I call myself a machine learner. Actually, if you followed me on Twitter, I used to refer to myself as a kernel trickster for a long time. Yeah, got that reference. I've been attending meetups just as long. I actually got my job from the NLP meetup, which I don't know is around anymore, but that was a really good one.
You can start it again if you want. You can start it again.
Oh, I haven't done NLP in so long. So I work in geospatial, which I take pictures from space. Yeah.
Cool.
And that can include a lot of different areas. So NLP, computer vision, time series. Over the 9 years I've been doing it. I've kind of done it all. I like to think so. Right now I'm solidly in computer vision territory, which makes me a little bit like everybody's on the LLM train, and I'm endlessly curious. Actually, so this talk has kind of come from just my own insomnia. I really love generalization. I first got into machine learning by taking the MIT course, the Caltech course online, and that was all about generalization theory. And I thought it was really cool, and I was really excited to use it. And then I kind of found out you never use it. So I'll be going over some relevant papers, some of my favorite ones. So there'll be a bit of a paper review, and then I'll kind of talk about some code bases that I found that are really cool that almost seem to have gotten unknown, and including one that I may or may not be working on myself. So yeah.
Cool.
Now a bit about generalization. If any of you have taken those courses, they will kind of talk about different generalization measures. So you have things like the VC dimension and the Rademacher complexity. It's a really big category, and I'm just touching, just doing the tip of the iceberg. There's a lot of talk about. I'm really just going to go over a couple papers, and kind of give you like a general overview. All right, now I like to do my favorite thing, which is describe the learning problem. So this will be a talk about machine learning, which is all over the place, right? From recommender systems. It's actually my Netflix. So you might be tipped off by all like the cartoons. To I think it was Capital One, where they're using machine learning in order to evaluate if people are posting their credit cards online. So yeah, computer vision and as we all know, language models, and so it's really everywhere. It's really everywhere. Like this is actually from 2019. This is just an overview of all of the different machine learning and AI companies, and it's really expanded. Just there's so many places that we're using machine learning data, and yet I feel like every once in a while, like the models may fail, right? So I think you've probably all seen news sources, or sorry, news articles like this, where maybe a self-driving car might, crash into someone, or a model might, be determined to have some kind of bias, and this is really a situation where these models are not behaving the way we expect them to, right? So when we train our models, we train them within a certain environment using certain training data, and then we set them up and we let them go into the wild, and they just encounter any number of situation. And how do we know if our training data is going to match sort of the real world?
Well,
it very often doesn't. Now, 10 years ago, when I was first getting into deep learning, we had several different ways of knowing it. So, and that's where we get into generalization. So what generalization allows us to do is it allows us to know how well our models are going to perform when we, when we have situations that we haven't really predicted. All right, now I get to my favorite thing, which is to just go over the learning problem. So almost every kind of model can be kind of forced into two different categories. There are regression models and there are classification models. So roughly speaking, a regression model is when you have some kind of underlying target function. We'll define it, kind of like the simple linear model. We've all kind of seen this from our base math classes. This target function will create, there we go. It will create some set of data, and that data is what we'll see in the real world, right? So this can be things like a credit score, or it can be a weather pattern. And from this data, we will try to fit a model. We'll create several different hypothesis functions, so several different candidate, in this case, linear models, and then we'll try to select the best one with the hopes that the model that we've selected matches what set the data in the first place, right? And the question we're always trying to answer, especially with these classic types of machine learning models, is what is the hypothesis function, or what is the hypothesis function that matches our target function? This is a kind of similar situation with classification. So in that case, your target function, instead of being just a simple function, it will often span an entire space where your data will fall into one area of the space or another area of the space. You create your candidate functions and you create your candidate data. And this is what we see in the real world, right? So the classic one is spam or ham, or you can do facial detection or object detection. And it's the same deal where you create a set of hypothesis functions, and from that, in both situations, we don't capture every data point. And that's why it's machine learning, that's why it's statistics. We can almost never expect to perfectly encapsulate what created the data points in the first place, but that's why we're doing machine learning, and that's why we're doing machine learning. So then the question is, how can we make a hypothesis function that we can trust? And that is like the eternal problem. So an important thing to understand about machine learning models is that the more they increase in complexity, the harder it can be for them to find the original target function. So for example, let's say you make a target function that creates a set of data points and you want to fit it with a linear model. We often will do this. That might work well and good, but your hypothesis function won't approximate your original target. And in that case, you're not really going to generalize. When you have more data points, it won't really be the case that your future data points are going to fit to the model that you've chosen. So then you may say, okay, let's make a really, 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 really complex function, right? Let's fit literally every data point. Yay! The only problem is when you try to do this, well, then you're really not approximating your original function. And this gets you into the classic overfitting problem. So you want to have some way of controlling how complicated your function is, right? And there are many ways of doing this. You can, for example, add some limits to the average of the weights. You can change your learning rate. You can do early stopping, just any different ways. And really, what you're doing is you're controlling the complexity of your function. And hopefully, by doing this, you can create a hypothesis function that matches your target function. It's going to be low to be underfitting. All right, good. You can see here that, so a bit of an explanation of what this is. The parameter at the top kind of shows you how powerful our model is. The parameter at the bottom shows you how well it fits the data, right? And you can see on the right, when we're trying to fit the data with linear functions, it barely works. This data was obviously not sampled from a linear function, right? So you're not going to fit it with a linear function. But when you try to fit, a too complicated of a model on the left, you also lose accuracy, right? So by tuning the complexity of the function that you fit, you can best find yourself to be in one that will generalize properly. All right, so that's sort of like classical. That's sort of like classical machine learning. There's one more function I want to mention, which is I believe it's X. Okay, so my favorite function, the support vector machine. And really, before deep learning was, coming into being, these were all the rage. I remember when I was working with NLP and I was making, data classifiers or natural language, essentially not natural language models, but I was making text classifiers. I was always using support vector machines. And the reason that these are so effective is because when they separate their data, they try to maximize the width of the boundary between them, right? So you create some plane between the data, and you try to maximize the distance that plane goes to each of your data points. When you do this, if there's any kind of subsequent data, it's much less likely to cross the plane. And an interesting thing happens. The number of the actual data points that will affect your function or will define your plane is really, really low. It's only the data points that are close to it, and we call those the support vectors. And what it will do is it will make a decision boundary that if there are any subsequent points, it's going to be unlikely for them to cross that boundary. So this was one of the best ways of making a machine learning model that will generalize to new data. Another important thing about support vector machines is they use this thing called the kernel trick, which is they approximate a really, really high dimensional space with just a simple function. That's going to kind of come into play later. But yeah, so these two aspects of support vector machines, they made them really, really ideal for when you're doing machine learning problems until deep learning kind of hit the scene, and that sort of changed everything. You would expect that a deep learning model would follow similar patterns, but if you ever go online and look at these models, the number of parameters is high. And there was a really good paper by John. And has anyone read the deep learning book? The one that says deep learning. It was the one that was done by I believe it was the Jan LeCun one, but it was done by Sami Bengio. I'm sorry, Joshua Bengio. No. Okay, so
Good fellow.
So this is one of his students, and he proposed this paper that said that we really have to rethink how we do generalization with machine learning. And the central idea is that deep learning doesn't follow classical generalization patterns, because the number of parameters in a model is really, 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 really high. We're talking about like millions of parameters, some cases tens of millions of parameters, some cases like hundreds of millions of parameters. If you're ChatGPT, it's like so many parameters, like the model costs like millions of dollars, and you increase the atmosphere by like 1 degree or something. And yet, despite this massive number of parameters, these models actually do generalize, and that's really, really surprising. So, they set out to figure out, well, why is this? What properties of machine learning, or sorry, deep learning models cause this to happen? And more importantly, how do you test it, right? So in this paper, they trained an architecture on both true labels and random labels, and they tried to see if the model can memorize the data, right? And more importantly, they tried to see if, regardless of how much you memorize the data, can you still do the really important thing you want to look at is the left graph. The model will always fit to the data. And what you want to think of happening is there's so many parameters in these models that all of the data points just kind of get embedded. Which is very weird, because you would think that with all these, if every data point is embedded into the model, when the model encounters a new data point, then it won't be able to recognize it. And yet that's not exactly what happened. So these are several different models that were tested, right? You'll notice in every situation, when the models were trained on the data, the training accuracy was really, really, really high. They basically almost all perfectly fit the data during training. However, the train actually didn't necessarily predict the test accuracy, because they would sometimes just give it random. That's kind of weird. Like you wouldn't expect this to happen typically. And more importantly, what the models train on the data almost completely doesn't predict how the models test on the data, right? So you can think, going back with that, that really, really, really advanced model, right? You would always expect that to fail, and yet, that doesn't happen. All right, so this is kind of mathy, but bear with me. They made a really, really interesting point about machine learning models, and more importantly, very simple linear models, right? So if you define a very simple linear model trying to fit to a series of data points. So here you have a set of weights, a set of input data, and a set of labels, right? And what we're trying to do is we're trying to find a series of weights that will minimize the loss between our hypothesis function, which is what we're defining with the weights, and our labeled data. So they essentially just write this as a simple linear problem, and they say that all we're trying to do is we're trying to solve a set of linear equations and find a minimum. However, in the process